All right, for the last problem that for these kind of tables and using the formula for geometric sequences that we talked about in class. Again, I'm going to start with the basic formula a sub n equals a1 times r raised to the n minus 1 power. So a sub n equals a1 times r raised to the n minus 1 power. So really all I need to know is, again, the first term, which again, I'm looking at the a-n column here, not the n. The n will come in handy later, but not right now. So I'm looking at the a-n row here. So the first term is 20 times the rate in which they're changing. So from 20 to 10, it's decreasing, but I need to know what can I multiply 20 by to get 10. The easiest way for me, again, is to take the second one, 10, and divide it by the first one, 20. So 10 divided by 20 gives you the rate in which it's changing, and it makes sense because it's halving each time. So my ratio is 0.5 or 1/2. So I'm going to write 0.5, make this into a times there. So 20 times 0.5 to the n minus 1 power. So if I was writing just a formula for it, a standard recursive formula, it would be a sub n equals 20 times 0.5 raised to the n minus 1 power. Now, where we get into using the explicit formula is basically when we plug in and simplify. So the explicit formula, like I said, we're not going to really worry about it. As long as you know how to operate using this, you don't necessarily need to know that it's called the explicit formula. So now, again, I'm going to look at the table and say, okay, they want us to find the sixth term. To find the sixth term, I just know that a sub n is now a sub 6. So just like before, a sub 6. And now I have 20 times 0.5 raised to the 6 minus 1 power. This is 20 times 0.5 to the 5th power. And 0.5 raised to the 5th power gives me that lovely decimal. Then I take that and I multiply it by 20. And so the sixth term is going to be 0.625.